Hello, everyone. Today is January 11th, 2023. This is the Kubernetes Data Protection Working Group meeting. So today we'll have a CPD update, and then we have a few quick updates, a few other caps. So Prasad, I will stop sharing. It's all yours now.
Sure. Okay, I can share my screen.
I don't see it yet. You can share.
Nothing yet.
You should have permission to share.
Yeah. Hold on. There are some security settings which is not allowing me.
Your co-host, you cannot share? You should be able to share. That's very strange.
Just a moment. There's some Mac level access, I think.
Oh, Prasad, it's on your client, I see. So you may need to update and come back into this meeting.
I need to close and reopen the Zoom app. I'll be right back.
Okay.
Sure.
Xing, should we readjust the agenda order?
Yeah, we can do that. Because I only have a very quick update. So while we're waiting, we can just okay. I'll just go from the last. This is a really quick one. So this is the content notifier. It's been there for a long time. I think there are still some comments that we have not got time to address. And then someone was asking whether we want to change the status from implementable to provisioner so that it could move forward. So team has this question. So I said, okay, let's try that. Basically, that's all I did. I didn't make any other change other than just change this to provisioner. And I'm still not sure how this would work if we change it to provisioner. I don't know if there's a better chance to get this merged or not. So, but anyway, I changed it. So let's see how it goes. That's all I can say there is we didn't really change the content of the cap. So that's this one. Did we get, let's see, is Prasad back?
Yeah.
Okay. Can you try again? Oh, let me stop sharing. Can you give a try?
It's disabled for me. I think you need to make ghost again.
Oh, okay. I see. Okay. Co-host. Okay, try it again.
Yeah. Cool. I hope you're seeing a Notion page.
Yes.
I can see it. Yes.
Awesome. Yeah. So I would like to update the thing we have been working on. So basically, we wanted to test the CBT APIs and see if it affects API server performance by if you increase load eventually, and how API server basically performs. So I would like to summarize the test I have been doing and summarize the observations. Yeah. So I have run a couple of tests. So I would like to walk you through the progress I have done. So for for a single node cluster with 4 CPU and 8 gigs of RAM, I had this setup basically. For observability, I've been using Prometheus and Grafana to monitor the resource consumption of Cube API server as well as the CPT API server. So this prototype I have been using is the API server that Ivan had hosted on the GitHub repo. And yeah, so talking about the environment, the first time I tried this on a single node cluster, and I had to basically tweak the API server.
Excuse me. So this one, does this one use the aggregated API server or not?
Yeah. This uses API server.
Aggregated API. Okay, so that's the basically based on the cap that's written right now, right? That's not using the volume populator approach, correct?
Exactly, yeah. That's the original one, the with one we have, proposed cap.
Okay.
Yep, that's right. Yeah, so I had to basically mock, I had to mock the data to respond, to send 512 blocks each time whenever we, query for change blocks. The API server would return the same number of blocks each time. And I am using K6 tool to basically run number of requests parallelly to basically, mock the clients or mock the users. So yeah, I mean, I won't go through all the runs. I would just, summarize the findings for the time's sake. Yeah. So with the, hundreds of virtual users requesting parallelly, with the K6 tool, this is the result we got. Only, thing to concern was the average response time we get. And so basically, as per my observation, I had to do some tweak in the prototype or in the configuration to, increase the performance. Yeah, so first observation was like, the API server needed more memory because of the data we have been mocking. And the next fix I had to do is, yeah, so with 200 virtual users requesting the CB change block data in parallel, the average response time we were getting was around 30 seconds. And after debugging, I found that it was due to the rate limiting on API server, and the rate limiting was happening on, so in the API server, for each request, we were trying to get, yeah, we were trying to get the driver discovery resource. So because of that, the rate limiting, KubeAPI server was applying rate limiting. And yeah, that's why the response was getting delayed. After caching the driver discovery response, we could improve it to, yeah, after implementing the caching, the average response time we got was around 6 seconds, which is definitely better than 27 seconds. But yeah, I think this is again not acceptable considering we have very low load. It's around like 200 virtual users querying it parallelly. Yeah, so I'm still trying to figure out if this is the, if this response delay we are getting is due to some limitations from QAPI server, or there is some tweak or, some implementation things we can improve at API server or the sample driver side.
Do you have any baseline? What is acceptable? Do you have any? If you mentioned that, I missed that part.
Yeah.
What would be acceptable, I guess?
So as per the Kubernetes SLAs and SLOs, right? Yeah, I mean, ideally it should be around 1 second, but this is just for core resources, not for CRDs. For custom resources, there is no guidance as such, but only thing we need to make sure that this doesn't affect the kubeAPI server SLAs and SLOs for core APIs.
Okay, but when you were doing the test, did you actually check the core APIs? Does that, I think you're only checking that for the CPTs, right? What
Yeah,
about
that will be the. Sorry to interrupt.
Oh, just did you check? Did it affect the core APIs?
Right now I'm just observing the resource consumption,
Mhm.
how much memory and CPU it's using. We don't see like much spike in that. But yeah, once we are kind of find out the issue why the response delays getting caused, the next step would be to excuse me, run these in parallel, run the Kube API server benchmarking whenever we are having the load applied on the CBT API server. I think that would be the ideal scenario to benchmark both the servers, I would say, Kube API server as well as Kube API server benchmarking under the load of CBT APIs. But yeah, before that, there are few things we need to find out, like why the CB change block APIs or CBT APIs are consuming that much of time, or I would say why there is a delay in the responses.
So Xing, like yeah, it has been a while since I wrote that code on the aggregated API server, but
Mhm.
as far back as I remember, like we don't call like the Kubernetes core API because there's nothing there we need. We only need like the volume snapshot content, as well as the new proposed like driver discovery CRD to find out where the driver is. So yeah,
Mhm.
so Prasad, like it'd be interesting to see, like, is it just like the call to get the driver discovery CR, or is it also like the volume snapshot and the volume snapshot content calls as well? Because I would think those would all factor into the latency. And
Yeah.
then
Mhm.
the other observation is also like I think if we want to measure latency, it would be interesting to measure the P99, not the average.
Mhm.
Because average
Yeah.
can be deceiving.
Right.
Like we want to know the tail latency, right? Because if you have one really high latency and then 5 really lows, then average to be it's just fine. But that one really high P99 can really be that very unpleasant user, unhappy user. So
Yeah. So as of now, P95, I think we are not hitting it's basically hitting the threshold. But yeah, to another point to note is since we are mocking the driver responses, each time we are just returning the mocked change block data. So we are assuming that the CBT calculation or the response from the CSR driver, we are getting in order of 1 since we are mocking the thing. So
right.
another thing we'll have to consider, while doing the actual end-to-end benchmarking. So right now it's kind of, we are getting the change block calculation in constant time, but that would also vary. As you said, we might add an overhead of getting volume snapshots and then querying to the CSI driver to get the actual change data. The only thing so in this setup, the only thing we are kind of simulating is the traffic flowing through the API server and checking if, in case of large number of traffic flowing through API server, if that is consuming a lot of resources from API server.
Got it. So sorry, how much what's the response payload again? Is it 512 bytes times 200 of
The
those
change block data
units?
size. Yeah. So each request would return 512 change blocks, and each block is around 200 bytes. But with the, since K6, with the K6, we can configure how many parallel users we want to simulate. So as of now, I have tried with 200 virtual users. So if you see the traffic or the data sent and received, it was around, that is not much, but this is 241 MBs. But again, with this small amount of data, we are kind of yeah, we are kind of, excuse me, this is the latest chart. Yeah, even with that much data, I think, yeah, it's not fast enough, I would say. So yeah, I'm trying to figure out what could be the root cause if there is some limitations from Kube API server. If there is implementation thing we can improve, I'm doing that. But yeah, I'm trying to figure out how we can make this faster.
Got it. Got it. Another question is like, so with the 200 CBT, so we are simulating the scenario where the CBT service is telling the user, hey, 200 blocks have changed, but we're just returning you 200 metadata entries,
Yeah,
right?
metadata, right?
Got it. Got it. And what's the average block size you assume? Like, I just want to get a sense of like,
Yeah,
how much.
it's around 200 bytes. And with each request, we are returning 412 blocks. So 512 blocks. So 512 into 200 would be the response size for each request. And yeah, we can configure how many parallel users we want to spawn during the test run.
Sorry, what I meant was like is the payload using the proposed like API or like structure that how like in the ACAP we talked about like
Yeah.
in the response we talked about like block size and all those other metadata. I just want to get a sense of okay, so 200 blocks have changed, but like how much data are we actually simulating in terms of like the change block, if that makes sense. So are we telling user that okay, 1 gig of data has changed inside the volume, or 2 gigs of data have changed under the volume? You know what I mean? Or am I? I'm not doing.
I understand.
I'm not doing a good job in describing like what I'm trying to say at this point. But it's okay. Maybe I can ask you those like
No, you want basically the raw data so you can figure out API throughput, I think.
yeah, not so much of the actual data size being
Yeah.
transferred. Like I'm just trying to get a sense of okay, 200 blocks have changed, but this really means like 2 gig of data on the volume on this has changed.
I
If
understand.
it
Wouldn't that depend on the block size, right? Since we
yeah.
are explaining the metadata that 512 blocks has changed, but it would depend on the block size, like to calculate how much data has been changed, right?
Got it.
And have you documented that assumption? I think you have, right?
If I haven't, I lied. That's a good point.
Yeah, I think that's fine. It's like maybe largely irrelevant at this stage. I'm just curious anyways. The other thing that we can try is also like because there were two things that stood out to me, right? So the CPU utilization of the aggregated API server is really low. Which means like it's not doing a lot of like heavy computation. I wonder if there's anything.
So again, since we are mocking the response, we are kind of skipping the volume snapshot get calls as well as the actual CSI driver gRPC call. I mean, we are calling the CSI driver API, but it's returning the constant request as of now, since we are
But
mocking.
yeah, but like maybe like from a somewhat like but from my naive perspective, I think if anything we would be memory bound, not CPU bound, because we are not doing any like computation, right? We're just making requests and then it's the
It's more
memory that, yeah.
like proxy. The driver is actually calculating and returning the response.
Yeah, okay. I mean, if that means like there's any way, if you were talking about optimization earlier, I think is that
Yeah, more of maybe the API fairness, APF, and other configuration if we need any that could be causing the throughput issues or something like that.
Yeah. Okay, cool. And then the second thing that I want to bring up is also like I think we discussed this previously. Also, like you know how like there's some like I think I saw somewhere in this doc that you use like kube state metrics to capture some of the Kubernetes cluster metrics. So there's like that you know if you remember like the SLO like alert that I show you that like the Kubernetes API server would usually be deployed with. I don't have the link. Maybe I'll share it with you. I think it'd be interesting to see like as we continue to load test this, like if that the SLO alert would fire. Because yeah, if I know at least OpenShift like if that SLO alert fire, then all kind of all hell break loose type of thing, right? Then
Right.
the the priority and fairness thing would really likely kick in. User will start getting alert on their dashboard and stuff like that. So they're just saying that in a nutshell, that's just saying that if this load continue, my API server is gonna die. Like over the next like however the the error budget windows is. So
Yeah, I think with Prometheus operator and if you enable Grafana, there is a default dashboard we get for API server, Kubernetes API server. It has the SLI dashboard where we can see if it's breaking the contract basically.
so this so the read and write. Okay, so the SLI is great. I think it's a good start.
Yeah.
But it doesn't have an alert, right? Like it doesn't fire an alert. Like we need to make sure like that those alerts don't fire and stay calm and not panic. Because right now, like looking at the SLI request, I assume this is like read and write latency. It just tells us how long. It doesn't tell us whether it is good or bad, right?
Sure.
But anyways, I can if needed I can help set it up too. But otherwise, it should be fairly straightforward. Other than you need to know how to deploy JSON net, which is yet another thing to figure out. Does anyone else have questions? Thanks, Prasad. This is great.
Cool.
Yeah, Prasad, is this a public URL that we can share in chat?
So as of now, it's on my Notion. I can maybe create a Google Doc and share the link.
Okay.
Yeah, that'll be great. Thank you. Just add that to the agenda doc.
Yeah, will do.
I think like sorry, Mark, go ahead.
Oh, and presumably the load test is I'm new to K6, so presumably that's just a JavaScript file somewhere. Is that also something we can put in a repo somewhere, or maybe wherever the KEP is sample code is? That's one thing, a detail I haven't torn into. So apologies if I'm asking a newbie question there.
Yeah, I'll put it on the same doc. So under the environment, like where we have mentioned we are using K6 tool, I can include the configuration file as well.
Yeah, or you can just like push it to the prototype GitHub repo that we have.
That's what I'm after. That would be great.
So yeah, I mean right now 200 VPUs is not that much load. It's not like we are testing against the real world scenario, I would say. So once we fix the performance issues and once we run, maybe around, I'm not sure how much the real world request would look like, but at 200 isn't that much, I would say. So we are still need to figure out the issues we are seeing in the performance, and then we would run the real benchmarking against Kube API server as well as the CBT APIs.
So Prasad, that's something that you are going to work on next, right? So maybe hopefully next meeting you can give an update. And hopefully it's
Yes.
fixed. Okay, great.
And so
Mhm. the the idea about like putting your test script into the GitHub repo is also just like, you know, if folks want to try it out, then we know where to find all the client script, then we don't have to rewrite it and stuff like that. It doesn't have to be
yeah.
you know, fully configured to be like the perfect real world scenario, just what we have right now.
Okay.
So that's why it's a prototype repo, right? Everyone knows it's
Yeah.
it's a
But
prototype.
good engineering is reproducible results.
Yeah. I think
Yeah.
like to I'm just trying to think where do we go from here? Because ultimately, right, I think this is great. I think now at least we have some numbers to look at, right? Because previously, before the holiday, it has all been like you know, we're guessing, we're making assumptions, we're pulling
Yeah.
numbers out of thin air. But at one point, like there will still come a time where we go like, okay, realistically, what is acceptable? Because as long as like this whole thing is unbounded, you know, like either like try to back up or CBT like 10 terabyte volume, which we all agree today is not uncommon. It's not uncommon anymore, those kind of data size. And then like even if it is like just 5 gig of changes there, you know, uh, it's still a lot better than scanning like the 10 terabyte volume and trying to back up the whole thing. But if it's a 5 gig of or 1 gig of like CBT, um, you know, you all get what I mean, right? At one point, it's still like do we maybe there needs to be an upper bound somewhere about realistically what we can push down to
Yeah.
the network. So I don't know. I don't have to. Um,
So yeah,
Yeah.
we can quantify that test case. And Prasad, I don't know if your test case can accommodate exactly those parameters, but that would be a good summary. And not only that, as Ivan is saying, we're kind of have now less hand wavy a benchmark that we can compare to any other implementation or any other approach, right? Because a lot of people will just say, "Oh, do it this way or do it that way," and again, we may be able to disqualify them by actually proving that they're not performant or whatever compared to where we are with this, perhaps, if that's the best way forward.
Yeah. I would also like to discuss about how we scope this. I mean, if you have to present this to, let's say, SIG architecture group,
Mhm.
should we wait for, the benchmarking Cube API server and the CBT API server at the same time and have the results? Yeah, would like to
So-
understand how we scope this performance testing.
I think I think that my current thought is like, again, it falls back to what we talked about before the holiday. And then Ben and some of us chatted a bit about this too. Like at one point, we just have to say something like, you know, if the CBT metadata is greater than X amount of bytes, then there's an error. You know, like you have to back up the whole thing.
Mhm.
We can't push this down the network. What the number is, what X is,
Yeah.
it's kind of hard to quantify at this point, right? You know, like the say for example, like realistically, we can push like I mean not realistically, so hypothetically, so you know maybe like again, right? We have to make assumptions about capacities and stuff like that. If like say we say okay, X is like 5 gig, you know, if you have more than 5 gig of CBT metadata, then we're not going to return
Mhm.
CBT entry to you. But you know, like if you're talking about 10 terabyte of volume, and then a 5 gig is like change, CBT is still valuable in that case, right? But
Yeah.
we won't be able to handle it because you know, or we just bypass the aggregated API server altogether. I think at the end of the day, it might come down to that, right? You just go back to like that first ever proposal we had almost
Yeah.
about almost a year ago, where we just do that 2-hop thing, and then we just say, you know, we're gonna not go through the aggregated API server. Because like one of the things that we brought up before the holiday was, we said like CBT is great when the backup delta or whatever is not big. If it is huge, you might as well back up the whole volume. But still, right? Like from a user perspective, it's like I know Tom and I chatted about this very recently. It's like if you have a 10 terabyte volume, and then like the changes are like 5 gig, is CBT is still valuable in that case, or like compared to like having to scan it. We say okay, we don't support more than 5 gig of CBT, but now like the fallback for the user is now I need to scan like 10 terabyte of volume. So that number is really subjective and dependent, right? Like so, but anyway, so I feel like at the end, like the approach might just end up being like going back to that very proposal that we have, the earlier proposal that we have, where we send them back a REST endpoint. We will still have all these networking architecture issue challenges, but at least like we can safely convince the architecture that our service will not bring down the whole like cluster or make the Kubernetes API server very upset.
Yeah.
Thinking that we may
I don't
not have to go to the SIG architect meeting.
Yeah.
Because just we need to convince those reviewers.
Yeah,
Okay.
exactly.
Right.
Yeah.
Yeah. So basically, if we can prove that, hey, here are some concrete record and show what is performance like, then we can ask them to take a look again.
Yeah, I think the discussion about bringing this to C architecture is more to like bring this challenges to a forum that we can get advice from, not so much to convince the entire architecture group, but more like, hey, we try like 4, if not 5, like different approaches now. How would how should we solve this kind of problem? I want to quickly just give an update on volume populator. So I think the last time we talked about it was the main challenge there is or 2 main challenges there. I think like for one, like folks have been concerned about like the provisioning of this extra like volumes to store CBT entries. I think someone gave the example around like, if you have one namespace and they're like, say even like 50 to 80 pods there, each pod has one volume, at least one volume sometimes. If you user try to, they usually user may want to back up the entire namespace, right? Not one workload at a time. Then you're talking about like in a short amount of time, the backup software had to manage like, X number of volumes within that one namespace. So that was like one of the if not the major primary concern there. And then the second one, which was more implementation details that Chang Chen pointed out, was as we get back all the CBT entries, like there isn't like an efficient way to like pass this like CBT entries, which is in memory, into that like pod that the volume populator will spin up, right? Our CBT service would get all the CBT entries. It had to dump it into like some sort of ephemeral storage in order for the I think it's called like the prime PVC and the prime pod to pick it up, to read it and then dump it into that final volume. So, and that in itself is not great. Now we're talking about like at least like 2 IOs, like from the.
Wait, hold on. I'm trying to understand if you're arguing in favor of the populator approach or against the populator approach. I can't tell.
Yeah, in my mind, like that's exactly the dilemma, right? I think like these are the challenges that we say why we may not want to go with the volume populator. Now, in my mind, though, I think like volume populator is at least it offer like more stability and reliability over the network. Like we trade off some like performance and resources for stability and reliability.
So I don't really agree with that, because I mean, at the end of the day, you're probably accessing the storage over the network. It's just a question of what protocol you're speaking. I really don't like the idea of storing what is essentially a message on a disk or something that pretends to be a disk, just to try to like lighten the network load. Because at the end of the day, you're doing network traffic to write it to the disk and doing network traffic to read it back off the disk. You haven't really saved anything. You've just basically hidden the IO cost in a place where the networking people aren't going to look so closely. It seems like a gimmick to me. I mean, if you have a huge volume and a huge amount of deltas, and you actually want to know what those deltas are, you're going to have to transfer that data over the network. And it should be pointed out that, like, assuming you follow up with an actual backup of the blocks the deltas referred to, that backup is going to be an order of actually several orders of magnitude more network transfer than the transmission of the deltas, right?
Of course,
So
yes.
It's always a win to transmit the deltas over the network and then use that information to transfer the volume itself, unless more than 99% of the volume has changed, right? In which case you're just wasting, but you're going to end up doing a full anyways, and you'll just do a more expensive version of a full because you'll transfer all the deltas that represent the full first. I can't imagine a situation where storing the delta information on a volume actually alleviates any problem. It just hides it.
Well, at least like that part of the networking, right? The writing to the volume is not going through like my understanding is like it's not going through like the Kubernetes networking, right? That part of the volume is between the part of the networking is between the storage and the volume populator, right? It's not going through the Kubernetes API server at least, and the control networking path.
But I mean, if that's really where the concern is it just the Kubernetes API? Then the obvious answer is just use some REST API that is fully outside of Kubernetes API. Just like, here's a REST endpoint, go talk to it.
Yeah, and that is exactly like the reason why the cap is being held up, right? Like the in a sense, like the we got some feedback from Clayton and David Eaton, so probably like it's going through the Kubernetes API server is going to be a no-go, no matter how we try to slice and dice it.
Okay, but then the fallback position is, okay, then we'll just use the REST API outside of Kubernetes, but it'll still be a network API and not some disk-based representation of the same information. And if anyone objects to that, then the answer is, well, after you get these deltas, no matter how big they are, the actual backup is going to be 100 times as big. So, that's data that's going across the network, period.
Yeah, and hence, like like exactly. It will be some sort of REST endpoint outside of the Kubernetes control plane, like network path, right? So which is like going back to like Ben, as you recall, like the very early proposal that we put together, we sent like a an endpoint to the caller. The caller is called that and stream the CBD entries directly.
Yeah. I thought the challenge that we were facing that was leading us towards trying to do something in the Kubernetes control plane was, what do you do when you have multiple CSI drivers and multiple backup softwares all running in the same cluster? How do you basically sort of ensure that everything can talk to everything and that the right thing can always happen, right? It's very easy to imagine one CSI driver and one backup software that are specifically coded to know about each other. But if we try to define an open standard where any CSI driver can talk to any backup software and multiple of them can coexist at the same time, then you need something in the middle that's sort of doing the translation or the routing from place to place, so that each thing can get the appropriate bit of information from the right place, and that they're all speaking the same language. And that's where I thought something like a aggregated API started to seem like it would make more sense.
That was one as I recall, like the multiple CSI driver kinds, the existence of the different kinds are not the main, were not the main challenges, because like, the CS, all the existing CSI sidecars, they already have a way to know, right? Like whether this is something that this is like something that I need to worry. This is a resource that I need to worry about or not, based on the driver, the CSI driver name inside the API or something, right? Like we send it a CBT request, and like maybe inside it there's a CSI driver name, and then the sidecar will say, okay, yeah, this is me, or this is not me. I think the reason why we moved to the aggregated API server was at least like the main rationale back then was like we thought like our payload will not be worse than the Kubernetes logs. It will not be worse than the Matrix server, which we presented in the cab, but that got shut down because like the justification was given by the architecture was this was logs and metrics. They were like, I guess like they consider that as like system calls or system payloads, whereas
Okay, well, I guess let's go back then to the idea of, you just have a REST endpoint sitting in a sidecar somewhere and then the sidecar is talking directly to the CSI driver through an RPC, and that the actual API mechanism is just the URL of that REST endpoint gets dropped into an object. And so you could have different CSI drivers, each with their own sidecar, each with their own snapshots, each with their own CVT implementations, creating these objects and different REST endpoints, and then the backup software just talks to it somehow. I mean, I want to see a POC with like two of each, at least two of each, two different CSI drivers and two different backup softwares, all coexisting in a cluster, talking, to the appropriate things, the appropriate times, and everybody's happy. If you can prove that like that's feasible, then, and that there's no secure, maybe it was the security that was throwing us off, because you want to make sure that like, just because you have this REST endpoint out there, not just anyone can go talk to it. You want to make sure that the client that talks to it can authenticate as a Kubernetes, present a Kubernetes, what do you call it, a token,
Yeah.
to get off, so that you can reject, attackers trying to get this data.
Yeah, so when I thought about it, I thought your router maybe was based on the provisioner name and would pick the driver that way, and it would at least get a token or something back used for security that'd be passed back from the router, and then from that point on, the backup software would have to use the token or some secret that was passed back from the router to establish a connection. Does that make sense?
It does. And then like in our one of our prototypes from last year was we used the something called like the RBAC proxy. So we didn't well, for one, like we don't want the CVT service to become a secret management, has a secret management aspect to it. So what we did was we used this RBAC proxy where, hey, send me your request, pass me your service account token, and then I'm gonna ask like the Kubernetes API server whether I can trust you. So at least that was the first pass on authenticating and authorizing the request.
Okay, so did that work out, or was there a reason not to do that?
I think if I can remember, I think what Prasad and I think he did do some I think that part worked. Then then we decided that okay, if we need a tighter like authentication mechanism, at least we can figure that out in like future version. But at least we know, at least I think I know like what the RBAC proxy will work. We can trust the Kubernetes API server to delegate.
As long as like the backup software can use the same credentials to authenticate to this thing that it uses to talk to Kubernetes, and we can do the authentication through some sort of proxy, so that the actual sidecar that is syncing these REST requests doesn't need any doesn't need to store any secure information. It can just outsource all of the actual authentication to some proxy. That seems ideal.
Yeah. Oh, now I remember. Sorry, Ben. Now I remember. Then we got into a discussion of what if the backup software is not within Kubernetes? Then it won't have to. It may not have the service account token. But of course, we can all like push that back to like beta.
Well, it may not have a
GA.
service account token, but it will need some credential because it's talking to Kubernetes to create the snapshots, and it's talking to Kubernetes to create the PVCs, and it's talking to Kubernetes to create these backups. So like it needs to be able to talk to the Kubernetes API, and whatever it's using, it should be able to use the same thing to talk to this REST endpoint.
It's
right.
It's about token most of the time, I guess.
It could be a user account, right? It doesn't have to be a service
Yeah.
account. It could be a user account.
Yeah.
Whatever it is, we should be able to authenticate it through the RBAC proxy. Hopefully.
Yeah.
And of course, the RBAC proxy. Sorry, the RBAC proxy would need to run as a sidecar. There was again a small discussion around. Okay, now do we want yet another sidecar inside the CSI driver? But there was a very
is that it's not a network service, it's an actual sidecar.
At least the client side is, right? There's a client side sidecar that needs to go and ask the Kubernetes API server, can I trust your service account?
Yeah, I don't understand. I don't understand why that would be a sidecar, not just like a library you could link into your binary.
It's an existing like project that we found from the observability group. I mean, there's nothing stopping us from like just
We can
embedding the code into our sidecar, right? So
you can just import the required authentication package and use this. We had
that's what I'm thinking is we're going to build a sidecar that talks to the CSI driver and has a REST endpoint, and somewhere in there you can just import whatever code we need to perform the authentication, which is going to include like a network round trip to something, right? Because we don't have access to the actual secrets, so we need to ask someone, hey, is this secret okay?
Yeah, I think
we had implemented this on the controller prototype, Ivan, if you remember.
Yeah, it's one of the 3 or 4 prototype repositories that we have out there.
Controller one, not the Aggregated.
Yeah, we just need to like invoke the token review API, and of course, like the Kubernetes API server will not talk to us unless we have a TLS cert that it recognizes. So, it's in the nutshell, like is doable.
Well, hold on. The sidecar is going to be running as one of the many sidecars of the CSI driver, so it will get the service account of the CSI driver that the vendor uses when they install the driver itself, right? Like each vendor that wants to implement the service will have yet another sidecar with the same service account, and it'll probably have some additional RBAC granted to it to enable all of this. And we get to specify what that is, right? Because for each sidecar, we say, these are the required permissions that you got to grant the service account that it runs under. So I don't see any problem with just, having another optional sidecar with a bunch of RBAC that it needs. And then it's up to the vendor to make that happen when they install their driver.
So, sorry, Ben, I didn't fully get that part. So you're saying like let the vendor like handle the request, the TBT request, authentication and authorization?
No, I mean I'm saying like all of the other sidecars, right? We have a provisioner sidecar, we have an attacher sidecar, we have a resizer sidecar, we have a snapshotter sidecar. Each one is in theory optional, right? CSI vendor gets to choose which of the sidecars they package up and install with their driver. And this would be yet another one of those where we would write the code, we would publish it, and then each CSI driver would choose to use it or not use it, depending on whether they implemented those RPCs in their driver to do CVT.
Yeah. Okay. And I think that's the okay. Yeah, that's the model that we proposed like earlier last year when the very first time we put together. Okay, yeah, okay, cool.
So one feedback I think we had got with this data path API was people or it's not the Kubernetes way of consuming APIs, right? So yeah, one feedback
Right.
was there should be a
But
Kubernetes.
the response to that is this API is going to be transmitting so much data that we don't want to do it the Kubernetes way, right? It's a data heavy API, and therefore it's been kicked out of the normal process for APIs, and that's why it's special.
Yeah,
I think we didn't know that last year when we were having those discussions, that it was the amount of data we were proposing to push through this was so much that even the architecture team would say no, we don't want that to even touch Kubernetes API server.
Yeah. I think at this we're at a stage where I feel like we can go back and say, hey, we did our due diligence. Actually, the aggregated API server was first suggested by it came out of the production readiness review, review. It was actually like suggested to us, not mandated, but suggested to us that, hey, why don't you guys check out aggregated API server? And I think we are at a point where we can say, hey, we did our due diligence for almost a year, and now we conclude that our original proposal might still be the right one if we want stability in the control plane.
Hey, so since the Prasad has been doing this POC, should he continue with this because he has downtime testing and he's going to check the performance problem? So I'm thinking that he should actually just continue with that. And then Ivan, if you want to go back and look at our original, previous POCs, and we can look at both together.
Yeah. I think what Prasad does is it still has a lot of value, because even with the independent REST endpoint, we still need to have publish some sort of benchmark, right? Because usually it will still come back to us and say, hey, yeah, aggregated API server control plane is out of the equation, but how much realistically as a user can I get and expect when I use the service? So yeah, okay, we can do that. Yeah, I can look back at the previous proposal in the previous prototype, whereas the benchmarking that Prasad does still has a lot of values in my opinion.
Sure.
Okay, cool. All right, I think that's all from CBT.
All right.
Thanks, everybody.
Thank you, Yuan Prasad. So I just have one thing that just quickly go over. So this is the voting group one. There are some comments, so I've just updated this CSI spec PR. So now we have a new group control service, and we no longer have a volume group specific messages and RPCs. So we only have a volume group snapshot CSRPC. So it's simplified based on the comments. So basically just want to get some reviews. Let me see. I think after my update, I don't see got additional reviews. Basically just to see now we do not have this voting group construct anymore. Is there any issue with this? Is it fine? So
Xing, that the review you want is for the CSI spec PR.
Yeah, because we need to get this one merged before we can do the cap. Right, this one.
Yeah, I've signed up to do the review and I haven't done it, so
yeah,
feel free to remind me and poke me if I.
Okay,
I'm slow.
Great. I will put this in your Slack. I will remind you to review this. Okay, I think we are running out of time. So that's all we have today. Thank you.
Thanks, everybody.
Thank you.
Everybody.